I believe that there were a few problems with hearing, so I'll use the microphone throughout. After Paul's very comprehensive presentation, where I think he covered the whole industry in perhaps like 100 years and lots of different facets in 40 minutes, hopefully one of the questions which are arising at the moment is, what are we actually getting out of the ground, and how do we get it out? And in this presentation, I'll be giving a few more basics, and hopefully some of these questions will be answered. Just to explain sort of very quickly why I'm in this position and sort of giving this presentation, my background, I'm a chemical engineer. I went through the process project operations type background. I ran offshore for about 5 years, and a combination of offshore, onshore, of a refinery for 6.5. Went into loss adjusting for about 4 years, and then risk engineering, and working closely with Robin and Jeff and Hugh and David since then. One of the questions which is normally asked at the beginning of my presentation is why in an insurance-orientated presentation like this, or insurance-orientated course, do we talk about oil and gas basics? And I think that the simple answer has to be that you must know what you're insuring. If, for example, you're a real estate agent, you must know if you're insuring a flat or a house or a factory building. Is it big? Is it small? And one of the purposes, one of the objectives of this particular presentation is to try and give some sort of understanding of that. Paul mentioned crude oil plants, he mentioned 150,000 barrels a day, 100,000 barrels a day. And the question, hopefully going through your mind, is that small, is that big? And in this presentation, that sort of thing will be touched on. So just sort of going through this, and I wrote this down after I got this sort of question after one of our energy courses, was the idea of this presentation is to give you an overall idea of what we're insuring in energy, to try and understand the risks involved. Unless you understand a little bit about the technology, you can't really understand the risks involved. And give an understanding of the products being handled, crude oil, gas. I think most people think of crude oil and gas as being two totally separate things, but in fact they're not. They actually come out of the well fluids as a mixture, and then they get separated. And if you can sort of understand that concept, lots of other things fall into place. Separation, why you have associated gas coming off your crude oil. It also explains certain of the risks, because crude oil on its own, when stabilized, is not that dangerous. But of course, wild crude oil with the gas still in it is far more risky. It also will give you confidence in your negotiation with various parties. If you can understand the terminology and the factors, this will certainly strengthen your case. You as underwriters, but if you negotiate with brokers, if you negotiate with clients, and you understand a bit of their terminology, then that's very much better. Claims analysis, absolutely essential with claims is root cause analysis. And so unless you sort of understand something of the process, something of the oil and gas, and what's actually happened, you can't really understand the claim. And of course, I needn't tell you as insurance professionals, but of course, for a claim, it has to be sudden and unexpected. It has to be fortuitous, and you have to understand that. Understanding the terminology, as I mentioned, and then also survey reports. Survey reports are sort of quite important, and of course, that's a major portion of my business is the actual doing surveys and compiling survey reports. And of course, there's lots of information in that. Things like EMLs and risks and the mitigation and the exposures and the importance of the recommendations. And I think you understand these things very much better after this presentation. And then finally, just this information which will make communication very much better. So that said, we'll start getting into this. What is ENP? What is seismic? Paul touched on seismic, so I won't be going through that in much detail again. But crude oil, it was mentioned barrels per stream day. Why is it measured in that? And of course, that's historical. It comes out of the US. 1 barrel is 42 US gallons, 1 US gallon, 3.8 liters. And the oil in those early days was measured that way. And because of that, virtually everything is sized on that basis. You know, flow rates are sized, refineries are sized, FPSOs are sized on the basis of thousands of barrels per stream day. Natural gas, strangely enough, is 1 million standard cubic feet a day. And I kind of go into the detail a bit more, but gives an indication of what's big and what's small. And condensate. What is condensate? Condensate it's the liquid that is normally associated with the gas find. And if I explain the hydrocarbon, which I'll go through very, very quickly without boring you all with high school chemistry, but it just gives an indication of a complete range of hydrocarbons and at what point they become liquids. And then a hydrocarbon deposit. A potential hydrocarbon deposit is identified from the seismic survey that you saw, and I've taken those slides out of this particular presentation to try and cut down on duplication. Yet, after the seismic survey has been carried out and the geological structure has been established as being conducive to finding hydrocarbons, one has to then drill a hole. And that hole then shows if there are hydrocarbons there. And the geology and the volume must be confirmed before it's worth actually developing that. Exploration well is drilled first. And I talk about the different types of well in this presentation, different types of wells, because this is important with your insuring, because each one has a different risk associated with it. And throughout the policies, there'll be different rates for the different types of wells drilled. And then if successful, then the well is completed. It was also mentioned, we talked fairly glibly about fields earlier. And of course, most of us think of a field like a football field or a cricket field or something. But of course, in this case, this is a subsurface field. It's the field where the hydrocarbon deposit is actually located. And the hydrocarbons are located in sort of layers, in structures in the ground. And the other aspect that I think quite a few people imagine, there's a great big pool of oil underneath there, and you sort of tap into that pool and oil comes squirting out. But in fact, it's not. It's like a solid sponge. It's like a rock sponge, and the hydrocarbons are actually contained in the pores in this rock sponge. So what then happens is to drill into that, and then there's a movement of the hydrocarbon fluids into the well, and I'll show you a picture of a well a little bit later. And so that's quite important, like the permeability of that rock, because if it's very, very slow, then you have to drill quite a number of wells, so the development of that field becomes so much more expensive. So just a couple of backgrounds on the risks there. Well fluids, as I mentioned, are a mixture of hydrocarbons. Natural gas, condensate, crude oil are all components of the well fluids. Natural gas is methane, about 95%, can be higher, can be lower, some ethane, and then after that it becomes well liquids, and then after that crude oil. Crude oil is usually C5 and heavier. When I talk about C5s, I'll explain this in a minute, but I think this is quite a basic thing. And if you come out of this presentation with one idea in mind, it's the idea of this continuous mixture of hydrocarbons coming out of the ground. And then LPG, Paul also talked about LNG, and I talked about the difference between LPG and LNG. Quite a few people ask me, what's the difference there? And that's quite an important difference because each, again, has its own risks associated with it. Crude oil, a mixture of heavier hydrocarbons. Production is measured in barrels per day, so just just keep that in mind. Natural gas is methane, primarily methane, and that's 1 million standard cubic feet a day. Condensate is the liquid which is associated with the gas. Hydrocarbon, it's a compound made up of carbons and hydrogen atoms, and just as a very quick indicator, C1C2 is gas, C3C4 is LPG, and C5 and heavier becomes liquid hydrocarbons. Don't worry too much about that particular slide. If it looks like school chemistry, it's just to sort of explain that the hydrocarbon chain is actually signified by the number of carbon atoms in the chain with hydrogens around it. So what's worth remembering is C1, C2, C3. And if you remember, C1, C2 is gas, C3, C4 LPG, C5, C6 is natural gas liquids, and then heavier than that becomes crude. And there's a slide a little bit further on. In fact, it's the very next one. This one doesn't have to take in all now, but this is a very useful reference slide, and it gives you, obviously lighter than that is gas, but then you start with the LPG. And the significance of the LPG and the risk involved there is that the LPG component C3, C4 form the vapor cloud, and a vapor cloud explosion is one of the biggest risks in the insuring of offshore platforms, refineries, etc. So that's worth remembering. And then naphtha, which is usually a feedstock into chemical plants, is that C7, C14. And of course, gasoline is C4, although not very much C4 goes into gasoline these days because it's used as a component for the actual starting of the engine. But unfortunately, this is now resulting quite a lot in fugitive emissions, so that's being taken out of petrol more and more. So just diesel is roughly C15 to C20. So think in terms of hydrocarbons. Think of these chain links. Think of this mixture coming out of the ground, and that this mixture then goes first of all into a platform where it gets separated, firstly, and then finally the crude oil goes into a refinery where it's then cut up into the different fractions. Right, quite an important descriptor of a crude oil is the API gravity, and so I'll just explain what that is and how it's defined. Sulfur percentage is quite important in crude oil. You know, the higher the sulfur, the less valuable the crude, and the more difficult it is to actually process it. Wax content is another factor, but wax content also very important in the effectiveness of the chemical dispersants that are then used in oil spill. So distillation range, this shows how much petrol, how much diesel, etc., can be taken out of the crude. Viscosity, how thick it is. Pour point linked to viscosity. And then contaminants, because these affect the processing and affect the catalyst. So just these definitions very quickly, and we needn't dwell on them, yet a question that might go through some people's mind is why is it that a heavier crude oil has a lower API gravity. And the reason for that is this is just a definition from the US, where it's 141.5 over the specific gravity minus 131.5. Why it is not clear, yet this is how it's developed, and all crude oils are described on the API gravity. Just sour crude, 1% sulfur and higher is generally a sour crude. Sour gas, roughly the same, 1%. So just sort of keep the 1% in your mind if that becomes an issue. Pour point, viscosity. This is a very useful slide. We needn't dwell on it now, but if I could just sort of pick up a couple of points, is that the heavy crudes out of Sudan have an API of about 28. So they fit in the region roughly of the Alaska North Slope of the Arab Heavy. And the Tapas coming out of Malaysia, the very, very light crudes, which are virtually diesel, they have an API gravity of about 44. Here, this Tapas is 45. The one coming out of our clients' fields is usually about 42. So that's the range. So between about 28 and 44 is about the range for an API gravity. And what's of interest here is as the crude gets heavier, and remember, as it gets heavier, it's more expensive to process because you have to then put in hydrocracking that breaks down the molecule. Usually the sulfur goes up, which in turn makes it more expensive because you have to have more equipment for actually taking out the sulfur. So that's quite a useful reference slide. It might be worth looking at your leisure sometime. Hello.
It's not your specialist subject, perhaps, but what is the price differential between, say, the Tapas, which I know goes to a higher than Brent, down to, say, maybe the Venezuelan heavy? Is it quite significant? Or is
it depends on the crude price at the time. But 2012, when I actually did that, and there's a slide. I'm glad you asked that question because there's a slide on it. It's about $6 a barrel.
I'm sorry, I haven't seen this presentation, so I'm...
No, it's no good question. And in fact, there's a differential between heavy and light, and a differential between sour and sweet, and that runs at about $6 a barrel.
Oh, really?
Mm-hmm.
The differential?
Yeah.
Oh, wow.
Okay. Right, shale gas. I don't know if there's any shale gas here in Kenya, but certainly it's becoming a big issue. North America, it's big. Quite a lot in Europe, and there's quite a lot of emotion kind of associated with it. But I think, and you know, one hears the stories about gas coming out of water pipes and all the rest of it. But I think the simple answer is that if shale gas production is properly done, then there's no problem. And coal bed methane it's the methane which is associated with the coal. And then tight gas really is gas which is not easily recovered, which then needs special techniques for doing it. And here's a slide just to sort of show what's involved with shale gas. I won't go into detail. In fact, if there are questions on this, maybe ask me afterwards and I can explain how it's done and how they put down high pressure fracking liquids and use a large amount of water and little beads that go into the structure and open it. It's a whole subject in its own right. And I could actually have a whole presentation just on that. So we won't hold this up for that. But if there is anybody particularly interested, please ask me and I'll go into it later. This is a bit more about the hydraulic fracturing process. Fracking, shale gas fracking, really, and it's a case of forcing down liquids that then force beads into the structure and the gas comes out of that. Right, what is a Christmas tree? A platform, a flow line, pipeline? Again, Paul sort of showed a lot of this, and hopefully the thought went through your mind, well, what is that? And it just goes quickly through it. A Christmas tree is a collection of valves that controls the flow of the well fluids out of the well. It can be on land, it can be subsea, or it can be on a platform. Traditionally, it was on a platform, as far as offshore was concerned, where you drilled straight down, had conductors coming up through, or we had flow lines coming up through conductors into Christmas trees on the platform. But what is happening more and more these days to actually have subsea trees where the whole Christmas tree is down on the sea floor. And just to give a rough, and once again, hopefully the thoughts going through, or questions going through your mind, where's the cutoff between having a platform, a fixed platform, or not? And it's roughly 100 meters. Going very much deeper than 100 meters, the amount of steel that you need for the platform stops really becoming economical. And then you should start thinking about a subsea type development. And a production platform, you saw a few pictures of production platforms, yet maybe I can give a little bit more depth in here. That's what the Christmas tree looks like. As I say, that could be down on the sea floor, or else on a platform deck, or else on land. And the next one's on land. Absolutely essential, because your two barriers are your triple SV, your subsurface safety valve, which is roughly 100 feet down below the actual surface, and then your master valve. So, and you have a master valve and a wing valve, and these are the two sort of key valves on your Christmas tree. So, from a safety point of view, absolutely key. At least one of those valves must be working at all times, and these are tested on a regular basis. Good. Thanks, Sean. That's a land Christmas tree. This was actually taken in Sudan, one of our clients in Sudan. And so that's that. Now we get onto platforms. That's just a general shot of a platform. And the next one actually breaks it down a bit. And this would have been built in around about 100 meters of water depth. And from that you can see that there's a drilling unit on it, because the drilling is done. I hope you can hear me now, but they drill from the drilling deck, and they drill sort of down and right into the sea, and there wouldn't be a Christmas tree down on the sea floor, and the well fluids then come up into the production area, which is here, into the production area, where it's controlled, and they'd have Christmas trees on the actual deck, on the production deck.